our sort of rules of differentiation, just quick whistle-stop reminder of those, is that if we've got x raised to a power, then the power comes down to the front and reduces by 1, so it becomes n lots of x to the n minus 1. If we've got a derivative of a sum or a difference, then we can just differentiate the terms separately and add them or subtract them as the case might be. The derivative of a constant, just a number with no x, is 0. And if we've got a constant times a function, then we can just differentiate the function and multiply the constant in afterwards. Let's just look at one example of that. So for example, if we've got something like 4x cubed, all right, we can actually pull the 4 out and just worry about differentiating x cubed. When we differentiate x cubed, we get 3x squared. So in fact, it's just going to be 4 lots of 3x squared, which would be 12x squared. Okay, right. Really, really important is that we can't differentiate something until it is what we call flat. No brackets, no fractions, and no radicals. This little formula over here, really, really useful for converting radicals, these root thingies, into things just with exponents. Okay, so we're going to do a couple of examples and then you're going to try some. Right, the first one over here, and we really have to pay careful attention to our notation. The first one over here, what we're going to do, notice d by dx means differentiate it. I'm not differentiating it yet. I'm getting it ready to differentiate it. This is x to the 4. All right, this is not entirely clear what's going on here. So this should actually be like that. So in fact, this is x to the 5 over 2. Remember that this is a square root, okay? This one is just root 2 times x, and the last one is root 3. Now, you might be tempted to try and change the root 3 into 3 to the half. Root 3 is just a number, all right? It's just a constant. Okay, notice I haven't differentiated it yet, and in fact, I'm not even going to differentiate it on the next line. I'm still going to write d by dx, which means find the derivative of. Now I'm going to multiply these two bases, which have got the same base, these two factors, x to the 4 times x to the 5 over 2, right? Remember, when we multiply, we're going to add the exponents. This is 4, this is 2.5. This is actually going to be 6.5, right? Plus root 2x plus root 3. Right, now we're going to differentiate. Right, and when we differentiate, we're not going to write the d by dx anymore. It's kind of run its course because we've differentiated. This will be 6.5 lots of x to the 5.5. It's just using our kind of power rule. The derivative of root 2 times x is just root 2, right? And the derivative of root 3 is just 0, and there's our answer. Okay, we're going to look at another one. Let's look at this one. This is using a similar notation, right? And this time what I'm going to do is I'm going to split this fraction, right? So I'm going to write it as two fractions, both of them over 8x to the 4. So the first one is 4x cubed, 8x to the 4, and the next one is 8x to the 5 over 8x to the 4. I haven't differentiated it yet. Now I'm going to write d, big D little x like that. This one actually simplifies too. Now, what we've got is we've got x to the minus 1, right? And we've got, essentially we've got 1 over 2x like that, right? And this one is, in fact, just x, which is nice. To write this one flat, I'm going to show you that we can actually write it like this. This is a half x to the minus 1, and this is plus x. And lastly, we're going to differentiate now. When we differentiate, we're going to bring the power down to the front. We're going to get negative a half. We're going to reduce the power by 1. And the derivative of, sorry, this I shouldn't have differentiated that x yet, because I've still got the notation there. The derivative of x is just 1. Okay, now this is the answer. It is good practice to write our answers with positive exponents, but if you don't have to if the question doesn't specify that. So that would be negative 1 over 2x squared plus 1. Right, and there we have it. Okay, let's do another one. Right, what we can see with this one is that in fact we need to factorize, right? So I'm just going to write equals here. This is still f of x. I'm going to start off by factorizing the denominator. Now this factorizes to 3 into x minus 2. Strong suggestion that x minus 2 is actually a factor on the numerator. Okay, so I'm going to take out an x minus 2 here. Now remember, I'm going to factorize this by inspection. Over here, I must have an x squared, and that x squared is going to give me this term, this x cubed term, when I multiply with that x. I must have a plus 5 here, because that plus 5 will multiply by that minus 2 to give me minus 10. If I was to multiply this out right now, as it stands, these two things would give me a product of negative 2x squared. I want negative 1x squared, so I need to add in 1x. And that 1x will multiply with this x to give me the other x squared. And this is now correctly factorized. If we want, we can just check that the x's are in fact correct as well. X's will come from x's here with numbers here. There's 5x. Or numbers here with x's here, and there's minus 2x. So positive 5x minus 2x plus 3x. Okay, what we can do now is we can divide that out and that out. Right, notice this is still f of x. I'm still going to write equals. This is still f of x. This x, each of these terms is over 3. I'm going to write them like this. I'm going to write them as a third of x squared plus a third of x plus 5 over 3. Only now am I going to differentiate this thing. And I'm now going to call it f dashed of x. The power comes down to the front and multiplies by this power. Now remember, this is 2 over 1. So the 2 multiplies with the 1 on the numerator here, and I get 2/3 x to the 1 plus 1/3. Right, remember third x differentiates to 1/3, and the derivative of 5/3 is just 0. And there's our answer. I think we've got one more. Let's have a look. All right, so this one is now with the y equals notation. This is a bit interesting. What we're going to do, we're going to square it out first. So this will still be y equals. When we multiply root x by root x, we just get x. Then we're going to get minus 2 lots of 2 root x. So minus 4 root x plus 4. Okay. Next up, we're going to get rid of this radical, the third, by writing this as x minus 4 lots of x to the half plus 4. Notice I haven't differentiated it. Only now am I going to differentiate it, and I'm going to call this dy dx. All right, or we could say y dashed. Okay, and what it's going to be 1 minus, now the half's going to come down, multiply with the 4, so I'm going to get half times 4 is 2x to the minus a half, and the derivative of plus 4, 0. There's my answer. With positive exponents, it will actually be 1 minus 2 over x to the half, right? Or, if we really want to show off, we can put this x to the half back into third form. So in other words, 1 minus 2 over root x. Okay, each of these answers is correct. Unless the question specifies, we don't actually have to move on from this one. Time for you to try some. Here's the first one. Pause the video, have a go. And there's the solution. Your second one. Pause the video, have a go. And there's the solution. A third one. Pause the video, have a go. And there's the solution. A fourth one. Pause the video and have a go. And there's your solution. We hope you found this useful.